Exponential equation problems on the digital SAT are hard, so let's get right to it. The equation you need to know is f of t is equal to a times 1 plus p over 100 to the t, where a is whatever you start with at time 0, p is the percentage increase per time period, and t is the number of time periods. This formula is most commonly used to model population growth and compound interest. You don't need to worry about compounding periods for the digital SAT, and if you're familiar with the equation for modeling exponential growth compounded continuously, forget about it for this exam. It's not relevant. That will only confuse you. Just memorize this formula. Here's an example. For the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 is equal to 14, which equation defines q? We start with 14 when x is 0, so that rules out a and b. The percentage increase is negative 45, so inside the parentheses we need 1 minus 45 over 100, which is 0.55, so the answer is C. This was a very mild exponential equation problem, but the test makers can make them a lot spicier than that. And one way that they do that is by switching the unit of time on you. To see what I mean by that, consider this example. The function f gives the value in dollars of a certain piece of equipment after x months of use. If the value of the equipment decreases each year by p% of its value the preceding year, what is the value of p? For this type of problem, the strategy is to use a test number to get a 1 in the exponent. So in this case, we want to know what the percentage decrease is when x is 12, and that would be 36 because 1 minus 36 over 100 is 0.64. This is a strange kind of problem that you would never see in an algebra course, so make sure you get some practice in my problem walkthrough video here. And once you're feeling comfortable with exponential equations, this next topic may not sound like it, but it is the hardest on the digital SAT: quadratic equations.